We're going to change tack right now. We're going to move from the hard science of nanotechnology to exposure assessment, and not just for foods. We're lucky to have Cronan McNamara with us from Creme Global. Prior to founding Creme Global in 2005, Cronan worked in financial risk analysis and derived option price modelling with Merrill Lynch. He moved to Trinity College in Dublin, where he adapted these mathematical methods to the food safety sector while developing the science and technology that underpins Creme Global. He holds a bachelor's in physics from University College Dublin and a master's in high performance computing from Trinity College, and has a postgraduate diploma in international sales from Dublin Institute of Technology. Cronan's going to talk to us about Nano Creme at Global, Nano at Creme Global, an Irish example, and he's going to talk about evaluating aggregate exposure of consumers to nanomaterials from food consumption, cosmetics, and personal care products. Thanks, Ron.
Thank you, Pat. So it's a pleasure to be here today. I did physics in my undergraduate, and we looked at nano a little bit in those days, but I have to admit I'm not an expert in nanotechnology. What I focused on since I graduated is to get into more of the risk analysis in terms of uncertainty, quantitating, and variability, and applying that to consumer exposure in particular. So it's really, really interesting to see how nanotechnology has progressed in the period since I graduated, and it's really come a long way. And it's such an exciting technology, and you can see the massive potential and benefits from it. So it's making a lot of progress, and I wish it would even go faster when you see the opportunities that there are with nanotechnology. On the other side of progress, there's a necessary precaution. So there's always a balance between progress and precaution, and that's what I'm going to talk a little bit today about. Some of our work touches on that topic. So I will talk about hazard identification, hazard characterisation, and how we look at exposure and potential exposure to consumers, and the methods that we've developed over the years to look at consumer exposure from different sources, and in particular aggregate exposure. So my talk will just introduce the company very briefly, then I'll move on to the hazard and exposure assessment and the different methods that we use. So we in Creme Global love data. We gather data from all over the world looking at consumer habits and practices. And what we do with that data is combine it with chemicals, contaminants, ingredients in those products to look at consumer exposure from all sources. So it could be anything from pesticides that the consumers are getting from foods they're consuming throughout the day, or it could be artificial additives, flavorings, sweeteners, nutrients, and in particular we've looked at engineered nanomaterials, but as I said, I'm not an expert in that. So how we do this is through our software models, which we have developed over the years. So we deliver this on all the data which comes with our models on consumers, and what they're consuming and how they can be exposed to different chemicals. It's delivered by a cloud computing system. So the benefits of that are that a large amount of data can be processed on this service, which would, if you use your laptop or your PC, would take hours to number crunch all of this data, but we can speed that up and do it on the cloud. So we do that analysis, and clients can log on and use that service. So the Food Safety Authority of Ireland were an early adopter of this system, and they're a big supporter of the data that goes into these models, so they can understand the consumers in Ireland and the potential hazards that come about from time to time, be it dioxins to horse meat and the veterinary drugs that may be prevalent in the food supply. So they can get answers to important questions using this data. We do analysis for our clients as well, so we work with government agencies, as I mentioned, including the Irish government, European Food Safety Authority, US government agencies, and many other countries around Europe. But we also work with industry to look at different questions around food packaging, the chemicals that are in packaging, how that ends up in the food supply and gets consumed by consumers, and other sectors from fragrances to others. So, as I said, we spend a lot of time on data, and we gather a lot of data and put it into our models and make it useful. So, we talked earlier about the good research that's being carried out in Europe and how we need to commercialise that research. So I've got good news for Commissioner Gagan Quinn and the people here from the EU Commission. that the original idea for this company came from a European Framework 5 project, where we set out to develop more advanced methods of food safety exposure assessment. And I worked on that during my time in Trinity College, and we managed to spin out that idea and that knowledge into a product and service. So I'm very proud to say that we've managed to go from EU research to a very viable and useful product and service which we can now provide to companies and government agencies internationally. So we do a lot of work internationally, right from Asia, started working in the Middle East, all across Europe and the US. So we started in food safety, and over the years we've developed new databases and models looking at various other questions, important questions from personal care products and cosmetics, crop sciences, food packaging, microbial contaminants, nutrition, which is a very important area, and we've done a lot of work on looking at reformulations of different categories of foods, like reducing sodium or reducing trans fatty acids, and the potential health benefits that can accrue to consumers and populations through that, pesticides and nanotechnology, of course. So this is the, you might have heard of the law of averages, but this here is the flaw of averages. So if you inspect the sign here on the river, you will see that he only knows one statistic about the river, the average depth. So this was kind of analogous to the way consumer exposure was done way back in the early days when we started the research in Trinity College. They did simplistic calculations of consumer exposure. So they might say, what's the maximum amount of apple a person could eat in a day? What's the maximum allowable residue of pesticide on that apple? Multiply those together and say, that's your exposure. And that's a conservative estimate of exposure because we've taken the maximum in both cases. But it doesn't give you an awful lot of information about the potential exposure across the population. People eat apple from a lot of different sources, and it could be recipes, and they could also be getting the same pesticide from different products, from pears, bananas, etc. So that's aggregate exposure, and you can't just add up simple conservative estimates. You end up with a very, very conservative risk analysis of the situation, which can hamper progress, as I said. So the analogy is, what we do is we keep all of the data on consumers and all of their diverse habits and practices, what they eat, what's in the products, in our model, and we can produce a complete risk profile across the population. So ultimately, it enables people to make better decisions about the situation. And you can see here, this character probably would have made a better decision if he had a bit better understanding of the total risk profile, not just one simple statistic. So that's the analogy on how we do what we do. So Creme Global specializes in the analysis of data. So there's so much data out there these days. You'll probably be familiar with the term big data, and there's just so much information being generated by research groups, by industry, by government, and making sense of this data isn't simple. So we specialize in actually trying to make that data useful to decision makers by doing analysis, publishing our methodology, doing good science so that we can produce trusted and accurate results that policymakers and decision makers can use to make better decisions and have confidence in those decisions. Be those decisions regulation or investment or making policy changes. So how do we go about risk assessment for chemicals or potential hazards in the supply chain from a food and a personal care product perspective? So I'm going to introduce some concepts which will be very useful then in looking at these types of questions for engineered nanomaterials. So in classical toxicology, what you would do is do some kind of study on animals, and you would increase the dose here on the x-axis until you start seeing some kind of effect or adverse effect. So that could be some kind of hazard or hazardous or genetic mutation or some kind of problem that you see with the system. So you can see here there's a point on the x-axis where an adverse effect starts to happen. You start to see a response. So you mark that as the no adverse effect level. And what they do then is divide that by 10 to go from the rats or the species that they're studying back to humans, and divide that by 10 again to make sure you're protecting the most sensitive human. So essentially you find the dose, which gives you no effect on the animal you're studying, divide that by 100 and say that's the safe dose per kilogram body weight for humans. So it's a fairly crude methodology, but what you end up with then is a dose that you're assuming is safe. So how do you know then that consumers are not going to get a dose exceeding that reference dose? And that's where exposure assessment comes in. So in the risk assessment process, once you identify something that could be hazardous, you do a hazard characterization via some kind of study that I just showed, for example, a repeat dose study, and you look for various endpoints or hazardous effects like cytotoxicity, genotoxicity, etc. You look for chronic or acute effects. This gives you the reference dose. And then you assess consumer exposure, or you try to set the regulations so that consumers won't be exposed to a dose which exceeds the reference dose. And that's the general methodology. So what we specialize in is the exposure assessment part of that process. So essentially it works like this. You choose your particle or nanomaterial of interest. You find all products that contain that nanomaterial, which is easier said than done because they're hard to detect. But if you can understand the occurrence of that nanomaterial across products and the usage and concentration levels it's used as, you can do that. Then in our databases we can input that information, and it can combine that information with those products and how people are using them. So it finds all usage events of those products for consumers across the populations you're interested in. It determines the exposure to the nanomaterial for each of their usage events. So if they're having a bioactive milkshake in the morning and then they're having some kind of product in the afternoon, it'll add up all of their exposures. And it determines the aggregate exposure for each subject. And then it looks across the population. So we have large databases of consumers, and we can look across all of the consumers in the database to understand the different exposures. And you'll get a risk profile of exposure across the population. So some people will have low exposures, other people will have high exposures. So you can understand that exposure distribution. So in a simple case, it will look something like this. You have most people in the middle with an average exposure in milligrams per kilogram per day. You have people on the left with a low exposure and people on the right with a high exposure. So remember, we have our reference dose. So you go back to your exposure distribution and you try to see where they sit relative to your safe level or your reference dose. And if you find certain people are getting exposed to a level higher than your reference dose, then you know you have some kind of safety concern there. And you can drill down into the data and understand what's driving those people's exposure. Is the concentration of the material too high in certain products? Or are people consuming a lot more of certain products than we expected? So, how do we do that for food products and personal care products? So, first of all, there's different types of exposure you might be interested in. You might be interested in people's exposure on average over a number of days, or you might be interested in a more acute exposure. So in a particular 24-hour period, what did consumers get exposed to? Or even more acutely, for more toxic things like pathogens, you might even get a hazardous dose from one meal or one eating event. So you can calculate different types of exposure outputs using this data. And you can even expand this to a lifetime exposure, so you can estimate over a lifetime what will people's exposure be to these compounds. So different graphs would be, you get different exposure distributions depending on whether you're interested in maximum day or daily average, etc. And the lifetime exposure would be slightly different to the daily average exposure. You would look at different types of exposure from absolute per unit body weight or per unit surface area. And all of this relies on real data which we've gathered and made available in our models. So we gather this data from many sources that we can access it and make it available. And this data is very detailed at the eating event level. And once you have access to that data, you can run your different questions through the system. So I'm just going to show a few brief examples here. This shows a lot of the different data sources which are available in the model. What you can do here is ask for different demographic groups. So I'm looking at the USA here. I'm looking at different types of consumers, and you can select age groups, genders, where they were born, whether they were born in the US or different ethnic groups. So you can drill down and understand the total population exposure or exposure for different important groups. You will get a breakdown of the exposure from all food categories. And then you input your information of interest, tick go, and click go. And then all of the data is crunched on the cloud and produces exposure distributions. So here we can see on the x-axis the exposure value in milligrams per kilogram per day. And then on the y-axis you see the P95, for example. So the P95 is a typical marker you might be interested in. So that means the 95th highest consumer in the population, what was he exposed to? And you can see here it's just under 0.2 milligrams per kilogram per day for this particular compound, or the 97.5th highest consumer. So often we look at the high consumer then in our distribution of consumers to see what level of exposure is happening. The other benefit of having all of the data in your exposure model is that you can see then which products are contributing to the exposure. So if you're interested in an artificial sweetener, for example, as we are here, you can see that sugar replacements or substitutes, soft drinks, fruit drinks, and tea are the only 4 categories that you need to be concerned about. Everything else contributes very little. So if you're trying to make policy changes or understand risk, you can see very clearly which categories of products you need to be concerned about or make changes. So certain materials, such as fragrances, can be used as a fragrance compound in a personal care product, such as a deodorant spray, a shampoo, or a conditioner, also used as a flavouring in food. So we call this total aggregate exposure. So we're developing a model now where we can calculate a consumer in Europe or the US, their total exposure to an ingredient or compound from the foods they're eating and the personal care products and cosmetics that they use on a daily basis. So we have a large database of consumers for all of these categories of products, which basically covers 99% of all personal care and cosmetic products that are used in the market. We have a large database of people using these products, so we can understand their habits and practices, and then calculate their exposure through dermal exposure, oral, and inhalation to various ingredients of interest. So you can see here, even looking at surface areas and exposure on different body parts is possible through this model. Just going to show briefly how you do this. So here you can see there's a large amount of information on consumers, what they're using. You can't probably hardly read this, but this is a diary file of, on a day, a time, the product people used, where they applied the product. So for 36,000 people over 14 days, we know what products they're using. So once you input the information on the compound or the ingredient of interest, then we can calculate detailed exposure across all of these habits and practices. We can look at EU or the US, different age groups, again, males or females. There's various compounds in the system ready to run. This one here shows you the different body parts that you can look at exposure across. Click go again, and this will run on the cloud and produce detailed exposure per kilogram body weight and per surface area for the ingredient or the material of interest across your consumers of interest. So, in summary, to understand hazard or risk, you first of all need to identify the compounds that you may think there's a hazard. Then you need to characterize that hazard by understanding what is the effect of that compound by doing repeat dose studies, or doing in vitro or in silico testing of that hazard, looking at different effects from chronic or acute, understand the safe dose for consumers, and then assess exposure against that reference dose. So what I'm saying today is that bottom part, we can understand that, we can do that bit, but I think for engineering nanomaterials, I think a lot of work is going to have to go into the top part of this, understanding the actual compounds that may cause a hazard or may be a hazard, and then characterizing that hazard and coming up with a methodology to understand what is a safe dose. And once you've done that, then we can get detailed exposure results for the population. So, thank you very much.
Thank you, Cronan. It's interesting to note that the European Food Safety Authority have only assessed 2 products, 2 nanomaterials, and I think, if I remember rightly, one of them might have been silicon dioxide or titanium, but it had 0 exposure because it was 0 migration from its packaging or whatever. So exposure assessment is a real serious part of the risk assessment methodology. Anyway, thank you for that.